Hello student, hi, good evening. So today we are going to see how to find the zero input response, zero state response and impulse response in signal and system and control system as well. So let's see, this is what topic is, what zero input response, zero state response and zero impulse response. Okay, so how to find these three? Okay, so this way, zero input response, zero state response and impulse response in signal and system, in control system. Okay, so I'm going to take here one problem. Through the problem we will understand how to find the zero input response. This is ZIR, zero state response ZSR, and this is impulse response. How to find the zero input response, zero state response and impulse response in control system and in signal and system. So let's see here. I'm going to take one problem. So that is what a differential equation that is given as y double dash t plus 5y dash t plus 6y of t is equal to x of t. Okay, so this is my differential equation of the system with initial condition that is given as the initial condition that is given as here y of 0 is equal to 2 and here y dash of 0 that is equal to what? 1. This is equal to 1. These are the initial condition for this system, and my input is given as x of t is equal to u of t. X of t is equal to, input is given as x of t is equal to e to the power minus t u of t. So this is given. Now for this system for which the differential equation is given, initial condition is given and input is given. Now we have to find for this what? We have to find for this zero input response, okay, and zero state response, zero input response, zero state response and impulse response. How to find this zero input response, zero state response, impulse response for this system with differential equation, with initial condition and given input. Okay, given input. Now let's see here. Now first we are going to find what? We are going to find the zero input response. First we are going to find what? Zero input response. We are going to find the zero input response. Okay, so now see here, in zero input response, so this is what first we are going to find the zero input response. If you see zero input response means what? For this input is what? Input is 0. Zero input response means input is 0 and the system response, that is we are going to calculate for the initial condition. Okay, so input is 0, here the response is due to initial condition. Here the response is due to the initial condition, okay, here the response is due to initial condition. Okay, now input is 0. So let's see how it is. So input is 0 and response is due to initial condition, as it is given that y double dash of t plus 5y dash of t plus 6y of t is equal to 0. Okay, here I am putting what? Okay, so this is what the differential equation. Here I am putting what? X of t is equal to 0. Why? Because zero input response means input is what? 0 and the response that we are going to find due to initial condition. What is initial condition? That is given as y dash of 0 was 1 and y of 0 was what? 2. Yes, so this was the initial condition. Now see here, now just by applying the Laplace transform, okay, by applying Laplace transform to this differential equation, as we know very well, dy dt means what? Dy dt Laplace transform is what? As d to the power n by dt to the power n. Laplace transform is what? S to the power n. Yes. Now for this, in this way, if we will find the Laplace transform for this, what we will get here? So Laplace transform for this is what? S square with initial condition s square y of s minus s y dash of 0 minus y of 0, then plus 5 into s into y of s minus y of 0 plus 6y of s is equal to 0. What we will get here by putting this initial condition here? What we are going to get here? Y of s take common, so here we will get s square plus 5s plus 6, and here it is minus, this is minus s, then here it is 5. Y of 0 is what? Y of 0 is 2, means it is minus 10 is equal to what? 0. Okay, so then what we will get here, I am going to rub this. We will get here y of s is equal to here s plus 10. When we will take this side, this become s plus 10 divided by, this will come at denominator, so which will be equal to s square plus 5s plus 6. Now see here, now we are going to make the factor of this. What is the factor of this? And also we are going to remove this also. We have used the initial condition for zero input response. Zero input response means response due to initial condition where the input is 0. So now see here, y of s is equal to, by making factor, what we will get here? S plus 10 divided by s square plus 5s plus 6 means what? This is s plus 2 and s plus 3. S plus 2, s plus 3. Now here, if you see here, by applying the partial fraction, just what you do, just keep the hand on this, and you see, if you see s is equal to what? S is equal to minus 2. S is equal to minus 2. S is equal to minus 2. Just put the hand here. S is equal to minus 2 means 3 minus 2 is 1. Okay, so this is what? 10 minus 2 is 8. 10 minus 2 is 8. So this is what? Plus 8. Yes, plus 8. Okay, s plus 2, s plus 3. We are just putting 2 here, minus 2 here, this become 1, minus 2 here, it become 8. So this is what? 8 by s plus 2. Then you just put s is equal to minus 3. S is equal to minus 3, minus 2 minus 3 minus 1. Here it is 10 minus 3 is what? 10 minus 3 is 7. Okay, so 10 minus 3 7. Here 2 minus 3 minus 1 means it is minus 7. So this is what? Minus 7. Minus 7 divided by s plus 3. S plus 3. Now what we will do here? Just what? As y of s is equal to what? This is what? 8 by s plus 2. 8 by s plus 2 minus 7 divided by s plus 3. Okay, so now here we are going to apply the inverse Laplace transform. So by applying inverse Laplace transform, what we will get here? Just remove this one. Now what we got here? Y of s is equal to 8 by s plus 2 minus 7 by s plus 3. Now by applying inverse Laplace transform on both sides, what we will get here? Inverse Laplace transform of this 8 by s plus 2 is nothing but 8 e to the power minus 2t minus here 7 e to the power minus 3t into u of t. So this is what? This is my zero input response. Yes, what is this? This is my zero input response. Zero input response. What is zero input response? 8 into e to the power minus 2t minus 7 into e to the power minus 3t into u of t. So this is zero input response where the input is 0 and my response is due to the initial condition. Now this is what? Zero input response. Okay, so now we are going to find what? We are going to find zero state response. What? Zero state response. Zero input response. Zero state response. Next is what? Over zero state response. Zero state response means response due to input. This means what? Response due to input. response due to input where initial condition is 0. Okay, so where initial condition is 0. Initial condition is 0. Okay, so 0 input, 0 state response due to input where initial condition is 0. Okay, so now see here how to find 0 input response. 0 input response means what was the differential equation, that is y double dash plus 5 y dash of t plus 6 y of t is equal to what? Is equal to x of t. Okay, now this time I am taking what? Input. Okay, so because 0 state response means 0 state response, initial condition is 0 and the input is due to and the response is due to input. Yes, response is due to input, x of t that I am taking, and I am taking here initial condition 0. Okay, so initial condition is 0 here, so this initial condition I am taking what? 0. Okay, so that is what the 0 state response. Now we are going to apply the Laplace transform on both the side. So what is that? If we apply the Laplace transform on both side of this differential equation, we get what? We get s square y of s again plus 5 s y of s plus 6 y of s is equal to what? X of s. Okay, x of s. Now here taking y of s common, and inside we are left with what? S square plus 5s plus 6 is equal to what? X of s. Okay, so now see here y of s is equal to x of s divided by s square plus 5s plus 6. 5s plus 6. So this is what output response in S domain for 0 state response. Okay, so this is what in S domain, 5s. Now see here we are going to find x of s for which the input is given. Okay, so let me rub this first. What we are going to get here, as we have obtained y of s is equal to what? X of s divided by s square plus 5s plus 6. Okay, so now where input x of t was given as e to the power minus t u of t. Yes, this was given. So if we apply the Laplace transform for this, what we will get? X of s as 1 by s plus 1. Yes, this is what the Laplace transform for this e to the power minus t u of t. Now just put this x of s into this equation. What we will get here? Let's see. By putting this here, we get y of s is equal to 1 divided by s plus 1, s plus, now making the factor of this, what is this? S plus 2, s plus 3. Now by applying partial fraction, what we will get here? S is equal to minus 1. So this is 2 minus 1, 1, and this is 3 minus 1 is what? 3 minus 1, 2. So here this is what? 1 by 2 divided by s plus 1, here s minus 2. Just put this, put here s minus, just cover this s minus s plus 2, put here minus 2, 1 minus 2 minus 1, here 3 minus 2, 1. So this means it is minus 1. So this is minus 1 divided by s plus 2. If you see here, now we are going to put here minus 3, minus 1 minus 3 minus 2, 2 minus 3 minus 1. So it become what? 1 by 2 again. Yes, so this will become 1 by 2 divided by s plus what? S plus 3. 1 by 2 divided by s plus 3. Okay, so if we put this s is equal to minus 3 and cover this and put in this expression, what we will get here? 2 minus 3 minus 1, here 1 minus 3 minus 2. This is 1 by 2. Yes, so what we got here? We got 1 by 2 and 1 by 2. This is what? Minus 1. Okay, so now we are going to apply the inverse Laplace transform to this. Okay, so then what we will get here by applying inverse Laplace transform? So we get here, let me rub this first. So this is what? Y of s is equal to 1 by 2 divided by s plus 1, and here minus 1 divided by s plus 2, here plus 1 by 2 divided by s plus 3. Now just apply here inverse Laplace transform. What we will get? 1 by 2 e to the power minus t e to the power minus t minus e to the power minus 2t plus 1 by 2 e to the power minus 3t into u of t into u of t. So this is what, this is my zero state response. Zero state response means response due to input where the initial condition is what, 0. Okay, so where the initial condition is 0. So this is what we obtained the zero state response. Now we are going to obtain the impulse response of the system. Okay, so now see how to find the impulse response of the system. So we are going to find impulse response of the system. That is what here, impulse response of the system. This is number 3rd, impulse response. Impulse response of the system. Now see here, for impulse response of the system means what? Means what? My x of t is what? Delta of t. Yes, my x of t is delta of t, and here the all initial condition is what? 0. All initial condition that I'm going to take as 0. Okay, so this is what? Impulse response. How to find the impulse response? Let's see. Impulse response of the system, as we have given differential equation, y double dash of t plus 5y dash of t plus 6y of t is equal to x of t. Okay, so for impulse response means my input is what? Impulse. Okay, my input is impulse, and the initial condition is what? 0. Initial condition is 0. Where for impulse response we get what? Now by applying the Laplace transform on both the side, what we will get here? We get s square y of s, same 5s y of s plus 6 y of s is equal to what? X of s. Now take y of s common here. What we will get here? S square plus 5s plus 6 is equal to what? X of s. So this is what? Y of s upon. If you see here, input, this I am taking as what? Impulse. Impulse means what? If you see impulse response, I am taking x of s is what? Because x of t is what? Delta of t. Then x of t is what? X of t is equal to what? Delta of t. Yes, then my x of s is what? My x of s is nothing but what? 1. Because yes, this is what? 1. Because the Laplace transform of impulse is nothing but 1. Okay, so this is what? 1. Now we can say that y of s is equal to what? 1 divided by, where x of s is equal to what? 1. Yes, 1 by s square plus 5s plus 6. 5s plus 6. Okay, so this is s square plus 5s plus 6. Now this is what we got, the output impulse response in s domain. So let me write this first completely, then we will see the impulse response. Then what is the impulse response that we have obtained? As y of s is equal to what? 1 divided by s square plus 5s plus 6. Okay, so then we can factorize it. So this is s plus 2 plus 1 by, this is s plus 2 into s plus 2 into s plus 3. Okay, so now by applying partial fraction, what we will get here? Y of s is equal to, s is equal to minus 2. This is what? 3 minus 2 is 1. So this is 1 divided by s plus 2, s equal to minus 3. This is minus 1 divided by s plus 3. Now by applying the inverse Laplace transform, what we will get here? Y of t is equal to e to the power minus 2t minus e to the power minus 3t into u of t. Yes, so this is what my impulse response, which is same as h of t. Yes, this is equal to h of t. So therefore my impulse response is what? Impulse response, zero input response, zero state response. What we have obtained? We have obtained, if you see here, first we have obtained what? Zero input response. Yes, zero input response is what? Zero input response that we have obtained as y of t is equal to 8 e to the power minus 2t minus 7 e to the power minus 3t. Yes, this was my zero input response. And zero state response, zero state response that we have obtained as y of t is equal to 1 by 2 e to the power, this is in bracket, 1 by 2 e to the power minus t, then here minus e to the power minus 2t, then plus 1 by 2 e to the power minus 3t into u of t. So this was my zero state response. Okay, then impulse response that we have obtained as y of t is equal to h of t is equal to e to the power minus 2t minus e to the power minus 3t into u of t For this zero input response means input was 0 and my response was due to initial condition. Zero state response means my response is due to input for which the initial condition was 0, for which the initial condition is what? 0. Here my impulse response, for this my response was due to impulse input. My response was due to impulse input. Okay, impulse input where initial condition was 0. Initial condition is what? 0. My initial condition is what? 0. This is what the zero input response, zero state response, impulse response of the system in control system and signal system. How to calculate that? The main basic concept is what? Zero input response means input is what? 0. Input is 0, then the response of the system is due to what? Due to initial condition. Okay, so here if I will write here, initial condition is not equal to 0. Initial condition is not equal to 0. Not equal to 0. Okay, and zero state response means the response is due to input where the initial condition is what? 0. And impulse response means what? Impulse response means my response of the system is due to input, that too also impulse. Okay, due to the input has impulse and where the initial condition is what? 0. So this is what we have. We have obtained zero input response, zero state response, impulse response for the given system in the form of a differential equation. Okay, so that is all about this topic. Okay, so thank you and bye bye, take care.